Hello friends, welcome to Ashok IT. This is Shekhar, Java trainer from Ashok IT. Guys, in this video, we are going to discuss a new feature added in Java 8, that is Lambda expression. So we are going to look into why Lambda expression is introduced in Java. Basically, Lambda expression is introduced to avoid creating multiple classes in our Java applications for overriding a single abstract method of an interface. And even it is also used to promote functional programming in Java. Basically, Java is well known for object-oriented programming, but Java 8 has given promoting the functional style of programming with the help of Lambda expressions, which means functionality can be provided as an argument to a method, or even we can store the functionality into a variable. So this is how the functional style of programming is introduced in Java with the help of Lambda expressions. So if you want to write a Lambda expression, we should follow a specific syntax. The syntax to write the Lambda expression will be like this. Let's look at this screen. I'm just creating within the comment, I'm writing how to write the Lambda expression. The expression syntax is first will be the arguments list. First will be arguments list, and arguments list should be in parenthesis, followed by arrow token, which is a symbol, then body of the Lambda expression. To separate this arguments list and body, in the middle we have to use arrow token. Basically it is containing three parts, and coming to arguments list, we should follow some specific rules while writing the arguments list. The first rule in writing the arguments list is the arguments types you must specify explicitly for each of the arguments, or they are automatically taken by the Java compiler. You should not specify the data type for any argument, but you should not specify data type for one argument and not for the other argument, and that will lead to a compile time error. That is the rule number one. And the rule number two, if there are multiple arguments in the list, or if there are no arguments in the list, then you must use parenthesis for the arguments list. And if there is a single argument, then parenthesis is optional. You no need of writing it. And the third rule, if the body of the Lambda expression has a single statement, which is a single expression, and writing the curly braces is optional. And it automatically returns the value, you should not use a return statement. If there are multiple statements in the body of the Lambda expression, then you must surround the body with curly braces. And you must use explicitly the return statement to return the value from the Lambda expression. And how can I able to understand whether I should return the value or not? It all depends on which abstract method that you are going to implement through the Lambda expression of your functional interface. Functional interface is basically, it is an interface which contains a single abstract method. For an example, if you take comparator. In Java, we have a comparator interface, which is a functional interface, which contains a single abstract method, and that single abstract method is compare, which has two parameters, like it is going to compare the first argument with the second argument. So this is one example for functional interface. Similarly, for example, if you know runnable, consider you know that you have something called runnable interface. This runnable interface has a single abstract method, and that abstract method name is run. It is also an example for the functional interface. So basically, for example, you have a list of employees. Now you want to sort the list of employees based on their salaries in ascending order. Or next, you want to sort them next time based on employee numbers in ascending order. Okay, or otherwise, For example, you want to sort the employees by their names in descending order. So if you don't use functional programming, that is with Lambda expressions, then you have to create more number of classes. Consider you should create one class to sort the list of employees in ascending order by implementing the comparator interface. You should override a single abstract method, that is compare method. And if you want to sort the same list of employees, for example, in employee numbers ascending order or in IDs ascending order, then you have to create one more class by implementing the comparator interface. So basically, if you start creating, if I have multiple sorting strategies like this, like ascending order or descending order on employee number property or employee salary property or department property, then more number of classes I have to create, which will definitely increase more number of classes into our application. So to avoid this, we can concise way of providing the implementation for this type of functional interfaces is using Lambda expression. So let's get started with some coding example. Consider here we have some list of employees. I have created first one class called employee, and this employee class has various fields like employee number, name, salary, gender, and department number. And we have created one constructor to initialize an object of this employee type with all its arguments, and we have various setters and getters for all the fields. And also we have overridden a toString method which can able to return the object into string format. So this is one traditional employee class we have with us. Now I have also created one class here, employee util, and which is to prepare the data, a list of employees we need, so that we can able to implement the sorting functionality with the help of Lambda expression, right? So I have created one static method here. The method name is called getEmployees, which returns me a list of employees, which is a collection object, array list object. So we have added some employees to this list, and finally this method is going to return us a list. Now we have the data ready and we have the employee class ready. Now we would like to see how to sort this list of employees in ascending order or in descending order by creating Lambda expressions without using any explicit classes for implementing the comparator interface. As we are aware that comparator is a functional interface which has a single abstract method, that is called compare method. But one thing, at the time of writing a Lambda expression, the expression we should construct based on abstract method that is available in the Lambda expression, in the functional interface. So our arguments list should match with the number of arguments in the abstract method of the functional interface. Consider we have abstract method called compare with return type is int. Example, this is the comparator interface. Assume that this comparator interface has consider an abstract method called compare with return type is int. Its parameters are t object 1, t object 2. Now at the time of writing the Lambda expression, my Lambda expression argument list also should contain 2 parameters, because the abstract method has 2 parameters and we are creating the Lambda expression to provide the implementation for this abstract method only. Okay, next, the body of the Lambda expression should return integer, because the return type of this method is integer. So whenever we construct any Lambda expression, it should provide the implementation for this abstract method. It should provide the implementation for the abstract method of the functional interface. So now we are going to use this with the practical. How we are going to write? Consider I am creating one method here. Consider I am creating one method. See, public. Consider I am creating one method which returns me a list of employee. This is get employees in sal ascending. So this is a list We are importing it. Now it will return the list of employees in salaries ascending order, and we would like to sort them based on salaries ascending order by providing implementation through Lambda expression. So how can we do that? See, first I want to create Lambda expression, and this Lambda expression I want to store it into a variable. This is called functional programming, functional style of programming, where the developer can provide functionality as an argument to a method, or even functionality can be stored into a variable. So into which type of variable I should store my Lambda expression, the functionality. So the functionality I can store into a variable of type interface. So for example, comparator of employee. Consider employee sal comparator. Employee sal comparator equals to. Now here I would like to write my Lambda expression. Lambda expression starts with arguments list followed by arrow token, then followed by body. So here what I will do, arguments list, two arguments are needed here. One argument is employee 1 and other argument is employee 2 to compare their salaries. Because compare method has two parameters. The arguments list should match with the number of arguments to the abstract method in the functional interface. So now consider I am taking two arguments called E1, E2, arrow token, then body of the Lambda expression. If the body has a single statement, then curly braces are not needed. And if the expression returns value, then return statement is also not needed. So here I would like to write more than one statement. If write more than one statement, multiple statements are there, then we should use curly braces. So I'm going to start writing curly brace. Now within curly braces, the first statement we are writing, if the first employee salary E1.getSal is less than E2.getSal. So E1 and E2 are the two employees. Now if E1 salary less than E2 salary, then return a negative integer value. Then else if condition. If E1 salary is greater than E2's salary, then return some positive integer, say 1. Else, if they are equal, then return 0. Let's import comparator. Let's import comparator. java.util.comparator. Okay, let's import comparator, and now we are going to keep a semicolon. Now this entire functionality which is implemented through the Lambda expression will be stored into a variable, and the name of the variable is employee sal comparator. And now we want to sort the list of employees by using this comparator. So first what I will do, I have a class called employee util which returns me list of employees. List of employee, consider employee is equal to, I have created one class employee util which has a static method called getEmployees which returns me a list of employees. And now I will like to sort all these employees, right? So to sort these employees, we have a sort method in list. So employees.sort, we should provide a comparator as a parameter. This is a method which is accepting an argument of type comparator interface. So we can pass our Lambda expression, the functionality, as a parameter to that method. So this functionality I have stored into a variable called employee sal comparator. So I am providing that particular variable as a parameter, nothing but it is a function style of programming where we are providing functionality as an argument to the method. Then it should return the list of employees. Now we would like to print all the list of employees, and for that we are creating a main method. Now I want to call this particular get employees in sal ascending. So if I want to call this method, I need to create an object for service class because it's not a static method. So I should call it's an instance method, right? So I should call it with the class name, sorry, with the object name. So service is equal to new service. So list of employees is equal to service dot get employees in ascending. Let us display by calling for each method. Let's see the output of this program. And now, as you can see, we got the list of employees here. If you observe the salaries of the employees, the salaries are started from 3,000, then next to 4,000, then 5, 6, 7. At the last, we are getting the highest salary, that is 9,000 for the employee. So which means what? We got all the employees in ascending order of their salaries. And how we are sorting them? We are sorting by implementing the functionality through Lambda expression. So if you want to sort in descending order, you no need of creating one more class to override the abstract method of the comparator. You can create the functionality directly through Lambda expression, and you can store it in a variable, and you can reuse that variable. If you want to reuse the functionality, you can store in a variable. If you do not want to reuse the functionality, then you can directly pass it, the functionality, to the method. This is called function style of programming. Consider the second way, without storing in a variable. See, we have something list of employees here. Consider, for some time, we want to keep this code in comment. For some time, we want to keep this code in comment. Now, directly we want to get the list of employees here. From the employee util, we want to call the get employees method. List of employees is equal to employee util dot get. I got the list of employees. Now, I am writing employees dot sort. But to the sort method, it is expecting a parameter of type comparator. But comparator is a functional interface. So we can provide the functionality as an argument because it is a functional interface. Functionality can be implemented through Lambda expression. So I'm writing the directly, I'm providing the Lambda expression as a functionality. So E1, comma E2, arrow token. Either I can write the code manually. Otherwise, in comparator, there is a method available called comparing double. So I can able to call the method called comparing double. So comparator dot comparing double, and I can pass E1 dot get sal, E2 dot get sal. I can provide the two salaries as parameters to the comparing double. Comparing double is a method which we have in the comparator. We'll put semicolon. I can pass directly through method reference operator, employee colon colon get sal. Okay, employee colon colon get sal. Now, we want to just simply sort the list of employees over here. Let me rewrite the code. The body of the Lambda expression I'm writing, arrow token. Then we are writing the code, comparing the salaries. If E1 salary less than E2 salary, return -1. If greater than, then return 1. Else return 0. So if you look at this code, without using comparing double method, if you use the manual functionality like this, to the sort method, we are directly providing the functionality as a argument to the method. And this is functionality implemented through the Lambda expression. Now, if you run this example, then the result will be same. So here, we are not storing this functionality into a variable. If you want to reuse this functionality, then you can store in a variable, and otherwise you no need to store into a variable. Now we want to display the list by calling for each method. Now when we run this code, now the output will be the same. You are getting from 3000 up to 9000. So the difference between the previous code and the current code is, previously we have stored this functionality into a variable, and then we are providing this variable as a parameter to the sort method. But now here, without storing this functionality into a variable, directly we are passing the functionality as an argument to the method. So like this, we can use a Lambda expression to sort the list of employees. Thank you.